every single company and organization and person should use multi-factor authentication. Multi-factor authentication reduces probably, this is not a hard-coded figure, somewhere between 20 to 40% of attacks, somewhere in there. Like the most popular attack in the world is social engineering that tries to get you to reveal your password. And if you're using MFA, that attack does not work. So try to use MFA, but I would encourage you, and every company should do MFA, try to use a form that is resistant to phishing. The whole reason you're moving from passwords to MFA is to try to prevent phishing.
Get MFA. You need MFA. MFA is necessary. Is that all you have been hearing these days? Well, the truth is that MFA implementations are easier than you think. But before the implementation, let's first understand the importance of building a secure MFA framework for your organization and clear all your doubts in this webinar with our returning guest, Roger Grimes, the Data-Driven Defense Evangelist for KnowBe4.
Thanks a lot, and thanks everybody for showing up. Just to let y'all know, besides talking fast, there's a lot of content, more than I can possibly cover in the next 30 to 45 minutes, but I think it's a good thing to download and read later on, like the book that it is. But again, if you haven't met me, I'm Roger Grimes, been doing this for 34 years now, and probably written close to 1,200 magazine articles, and a lot of them on multi-factor authentication. And I've been also, for 20 years, I was a professional penetration tester, and I was paid to break into MFA solutions, which I always did. Although I was paid more often to actually implement MFA, which I did for 20 years, hundreds and hundreds of projects. But through that, I learned a lot about the different ways to hack it, and also the different ways to make it stronger. And that's what I hope to communicate today. I even wrote a book called the Hacking Multi-Factor Authentication that you might see in the left-hand corner. That has I share over 50 ways that you can hack all kinds of different MFA solutions. I work for KnowBe4. We're the world's largest integrated security awareness training simulated phishing platform vendor. We try to teach people not to be phished, because social engineering and phishing is a really common way to get around and to hack multi-factor authentication. We'll talk about it. I'll give you lots of examples, give you some recommendations. But again, I'm going to run out of time. So at the end, I'll cover it fast. I'm even going to show you a video of infamous hacker Kevin Mitnick hacking some MFA. So I hope to give you a really good cross section of different ways to hack MFA. But MFA, just to say, we know that when you're trying to authenticate to a digital computer system, that you need to provide authentication factors. There's the three traditional factors, like something like a password or a PIN, or you're connecting dots or something you have, like a USB token or smart card or something you are, which is like biometrics, which would be like facial scan, fingerprint scan, retina scan, even smell. I was once on a U.S. Army project where we're trying to identify people based upon their smell, and we could reliably tell different people based upon their smell. But if they ate a lot of garlic or they drank alcohol, then it kind of ruined it. So it ended up falling away. But there's also a lot of other factors. When you try to log on today to a really major website like Microsoft or Gmail or something, they not only try to use one or two or three of these regular authentication factors, but they also try to look at, where are you coming from, what country, what location, what browser are you using, is the same browser you usually use, and that sort of stuff. Is the thing, operating system. So there's really a whole lot of other authentication factors, contextual, behavioral, that will sometimes play. When I was at Microsoft for 11, 12 years, to log into Office 365 or Azure, what it was at the time, they looked at over 200 different factors to determine, are you who you say you are? But if you just have to provide one of those factors, let's say like a password, that's called single factor authentication. If you provide two of those factors, it's called 2FA, two-factor authentication. If you provide two or more factors, we can also call it multi-factor authentication. And just know that you're supposed to use different types of authentication. You shouldn't use like two things, like they shouldn't ask you for a password and a PIN, because both of those you could be phished out of. The idea is if you use two different types of factors, like a password, and also have to have a USB key, that it's more secure. So all things considered, you want to use different types of factors when you authenticate. And also, I'm going to show you a lot of ways to hack MFA, but just know that usually MFA is better than 1FA. So we don't, just because I can show you how to hack around it, don't get the idea that I hate MFA, because I don't. I like MFA and you should use it wherever you can. But it's just that MFA isn't unhackable. And a lot of people think that when they're using MFA that they're far less likely to be hacked. And that's partially true, but not all the way true. You can still be very easily hacked when using MFA or most MFA solutions. So we're going to start off with one of the most common types of MFA hacking. And this is where an attacker, if they can convince you to click on the wrong link, like they send you an email and you think it's going somewhere that it isn't, but they trick you, they socially engineer you into clicking on a link. What it does is it can send you to a fake website that the hacker has created. We call it the man-in-the-middle proxy website. Then that website can connect you to the real website that you thought you were going to. So now that hacker's website, it has a man-in-the-middle connection between you and the real website. But everything that you type, including your password, your PIN, or whatever, going to the real website, they can capture, and everything coming back from that website, from the real website, goes through that proxy, and they can connect and capture what the website sends back. So another way that they can use this attack is that whenever you successfully authenticate to a website, the website always sends you back what's called an access control token, which is on a web browser, it's just called a cookie. It's just a text file, but that text file is essentially kind of your driver's license to say, oh, you've been approved, you've successfully authenticated, now you can be on this website. But if the attacker captures that access control session cookie, they can steal it and then replay it and become you. And that's what this attack is going to show. Actually, Kevin Mitnick, he's going to show you, it's called network session hijacking attack, but he's going to show you how easy it is to do and how easy it is to compromise MFA. And essentially gets by MFA like MFA isn't even there. And this works against probably 70, 80, 90% of MFA. Most MFA can be defeated using this method. And again, it's the bad guy convinces the victim to come to a rogue lookalike website that then proxies them to the real website. And then everything the victim puts in gets captured. Everything the website sends back to the victim gets captured. In this case, in this example demo that Kevin's going to show you, everything, he's going to capture the login name and password and access control token, and then that will be used to compromise the victim's session. So it's a really common type of attack. It's been going on for decades. It's been done millions of times, and it's very successful. And again, probably 80, 90% of MFA can fall to this attack. All you got to do is convince someone to click on the wrong link, and it's kind of game over. I got a link here, so if you want to go look at this video later on, you can. But let me be quiet and let Kevin Mitnick, one of the most notorious hackers in the world. He's also KnowBe4's chief hacking officer. It's a really good demo to watch. So I'm going to shut up and let y'all listen to it.
Kevin Mitnick, KnowBe4's chief hacking officer. So I'm logged into my Gmail account, and if you take a look in the second email here, I'll go ahead and open it. It appears to be an email from LinkedIn. And ordinarily, when somebody wants to join your network on LinkedIn, LinkedIn will actually send an email to your email address notifying you of that. And if you're interested, you can go ahead and click interested, log into your LinkedIn account, and authorize that person to actually become a connection. So if we take a look here, we have an email from LinkedIn that says, Kevin, I've read about your adventures and Ghost in the Wires and so on, and this person wants to join my network. But this is actually a phishing attack. If we take a look here at where the email is originating from, it's not at linkedin.com, it's at this domain called llnkeb.com, which people might overlook. So let's go ahead and pretend that we're the victim here and go ahead and click on interested. And what that is going to do, it's going to redirect us to the LinkedIn website to go ahead and log in. But let's move this over to the right and let that load. And if you take a look over here, we have a blank white page, which is going to become very important in a moment. And this is the attacker terminal session. So let's go ahead and bring back the virtual machine that's now connected to LinkedIn to authenticate, because we, again, clicked on interested in the email. So we'll go ahead and put in a username, Johnny Boy at mitnicksecurity.com. And now we're going to go ahead and put in our secret password. And then we're going to go ahead and click sign in. And when we click sign in, it's not going to allow us to log in. What LinkedIn is going to do is request our two-factor authentication code that LinkedIn is going to actually send to my mobile phone. And in a moment, you should hear a sound that the text message was received on my mobile phone. So let's go ahead and click sign in. And here we go. It's telling us that two-step authentication is enabled. We just heard a message come into my mobile device. We're going to uncheck this box that says recognize this device in the future. And I'm going to open my mobile device to take a look and see what the text message is, or what the code is rather. So the code here is 421-476. We're going to go ahead and click verify. And when we do so, it's going to log us into my LinkedIn account. So now we're logged into the LinkedIn account, but let's take a look at the attacker session over here on the left. So we're going to scoot this over to the right. And over here, what we have is what we're able to intercept. So we're able to intercept the email address, which is johnnyboy@mitnicksecurity.com. We're also able to intercept the password to the account, which is no before rocks. And over here, this is not the actual 6-digit code that was intercepted, because you can't really use the 6-digit code again, the second factor. But what we're able to do is intercept the session cookie. And if you're able to steal the session cookie, or rather the attacker is able to do so, they don't even need your username or password or second factor code. They could simply load the session key into a browser and they actually become you. So let me show you how this works. We're going to highlight the cookie. We're going to copy it to the clipboard. And then we're simply going to open up Chrome in incognito mode. And incognito mode just means with privacy. So now we're going to go to the real LinkedIn website. When we go here, obviously we're not authenticated. Now it's, wants us to log in with our credentials, but we don't have to do so. We're going to go ahead and go into developer tools. We're going to go into the console. And what we're going to paste into the console is the session cookie that we stole from the victim, which was myself, by the way. I'm going to enter it. I'm going to head and close the session. Now, all I simply have to do to be logged into the victim's account with their session cookie is simply hit refresh now. So I hit refresh, and here we are. We're logged in, or rather hacked my own account.
So again, and that's, most people that have not seen that video before are pretty amazed. And again, this works against most MFA. If you're asked to input a code or type in a code or something like this would work against that. The way that Kevin pulled this off is he used some open source software called Evil Jinx. It's a really popular software that anybody can download. And really there's dozens, maybe hundreds of others of tools similar, just like it. And again, this works against most MFAs. If I can trick you into clicking on the wrong link, it could be game over. This has been used in millions of real world attacks. Here's somebody complaining about it back in 2018. He got pushed to a fake Binance website. Binance is a kind of a cryptocurrency buy and sell website like Coinbase, and they stole his login credentials. And he was using Google Authenticator, which gives you, that 6-digit code. And they were able to take that code and then log in as, steal it and log into the real website and steal his money. Very, very common. Here's some other ones, other news stories. Iranian phishers bypass 2FA protections offered by Yahoo Mail and Gmail. It says, in the event that the target accounts were protected by 2FA, the attackers redirected targets to a new page that requested the one-time password. The victims then typed it in, they captured it and took over the person's session. It's a really, really common type of an attack. Here's a brand new other type of attack called Man-in-the-Endpoint Attack. That was man-in-the-middle attack that I just showed you, this man-in-the-endpoint. And the idea is that if someone has compromised your device, you've been tricked, and installing a Trojan, or you were unpatched and now an attack or malware's on your system, your MFA doesn't really work, because they can do anything that you can do, including they can actually start a second hidden browser session. These were originally known as Bankos Trojans, and that's because they happened a lot in South America and Brazil early on. And the first time I wrote about Bankos Trojans was in InfoWorld magazine in the early 1990s. But Bankos Trojans, what they do is the Trojan breaks in to your computer, it hides, and then it monitors where you go on the web. And then when you go on to like your banking website, it waits for you to successfully log in with or without your two-factor authentication token. But when you successfully log on in, it then comes awake and it steals your money. So you think you're checking your bank account to see how much money's in there, and they're actually transferring all of your bank account to some, Russian or Chinese bank account or something like that, that you don't normally deal with. These are very, very common attacks, have been done millions of times throughout the world. Here's a news report of just one of these kind of Bankos Trojans, banking Trojans. This was a criminal gang called Gaznim. They stole, it said 11 members of Gaznim stole $100 million from 41,000 victims with the help of a stealthy banking Trojan. And again, the overall banking Trojans likely steal billions and billions of dollars every year. There are hundreds of these gangs that make these banking Trojans. Here's like another example where you can go watch the video later on. I don't have time to show you the video today, but basically this is an app that pretended to be an Android optimization app, so like you're worried about your battery, running out of time too often. Well, if you got tricked into downloading this Trojan app, instead of it optimizing your Android cell phone, it would wait for you, it would stay hidden and wait for you to log into PayPal. And once you logged into PayPal, it would do this macro and then transfer all your money to the attacker's bank accounts. And those sort of things have been around forever. Almost all the new mobile Trojans for mobile phones have this sort of capability of doing man-in-the-middle attacks and stealing your MFA credentials if you type them in. Like in this particular case, it's a Trojan called EventBot. And it says EventBot targets over 200 different financial organizations, including bank, money transfer services, and cryptocurrency wallets. And again, it says here, said even if you use 2FA, but it intercepts the 2FA authentication codes as well. So very, very common. So even if you're using MFA, it doesn't care. It just waits for you to log on in. If you have to type in any MFA codes, it grabs that information, sends it to the attacker, and they use it. A completely different type of attack is short messaging service, SMS-based MFA. And let me say that SMS-based MFA is a very hackable type of MFA. The US government has said not to use SMS for MFA since 2017. Despite that, it's probably the most popular type of multi-factor authentication used in the world. Many different ways to attack it. But here are some real examples of MFA, SMS-based MFA codes that I get, where I'm logging into my Bank of America account or Facebook or Office 365 or Marriott or whatever. You get this code to type in. And all of those codes can be man in the middle, just like I talked about before. But there's many other ways to steal those codes as well. One way is to do what's called a SIM swap. SIM stands for subscriber identity module, and that's this area of memory. It used to be actually a little SIM memory card that you had to put in your cell phone behind your battery or in this little slot. Today, it's just usually a memory area in your phone that essentially makes your phone, that ties your phone number to a particular vendor's network, like AT&T or Verizon Wireless or whatever. And attackers can trick the phone company into sending their phone that they bought at the store somewhere, some random phone, your SIM information. And when your SIM information gets sent to the attacker's phone, all your phone calls going to you and all the SMS messages will get sent to the attacker instead. And if your phone gets compromised this way, you don't even know that it occurred. Your phone just says out of network on it. And it usually takes the average victim hours to know that anything's gone wrong. And then they think they're just at a network or something. It takes them quite a while to then call the cell phone company. They've got to use somebody else's phone. And then they find that the phone company's like, oh, well, you asked us to transfer it to your new phone. The person's like, I don't have a new phone. And they figure out they've been scammed. So these SIM swapping attacks have been going on for over a decade. They've resulted in the theft of billions of dollars of money and cryptocurrency. But essentially, again, that the attackers get your phone number, transfer it to their phone, and then they go reset your bank accounts and stuff like that. Your cryptocurrency accounts. And they ask to log in via SMS code. Those codes get sent to the attacker's phone that the attacker then uses to steal your money. And it's a very, very common type of attack, again, been used to steal billions of dollars. Probably the biggest one I ever heard about was 24 million bucks. This guy had $24 million of cryptocurrency stolen, and he sued AT&T for like $124 million. I'm not sure what happened in that case, but it happens all the time. Reddit, they used SMS-based MFA for their admins, and those codes got SIM swapped, stolen. The attackers logged into Reddit and compromised customer accounts, stole information. I think they even inserted some Trojan code, but very, very common for these SIM swap attacks. And, you don't really even have to be an attacker. If you got 16 bucks, you can actually send a letter of authorization to hundreds of companies on the internet and say, oh, I need you to transfer Roger's SIM information to my phone. You're supposed to have this legitimate reason for the reroute, but you can be anybody, and people have done this to test it. But for 16 bucks, you can get anybody's phone number routed to your phone, and so on. So this is, it doesn't take much to make up a fake letter of authorization and give somebody 16 bucks to transfer someone's phone number. The defense is don't use SMS-based apps if you can. The problem is that you don't usually have the choice. Your vendor or the service you're dealing with sends you the SMS code, and you don't get to say, don't send me SMS or something like that. This is another type of problem with SMS. Like when you get an SMS message, you have no idea who it's coming from usually. Phone numbers can be faked. You don't know who they are. It's like if I knew that you use Gmail, I could send you an email or an SMS message claiming to be from Google. I could say, hey, I'm from Google Security. We've detected a rogue sign-in to your account. We need to determine whether you or the other person is the real person. So we're going to send you a code from another Google support number. You need to retype that code so we can prove that you are who you say you are. Otherwise, we're going to lock your account permanently. And then the attacker would just go to Gmail. They know your email address, put in your email address, tell Google they forgot your password. Google says, oh, do you want to put in your last password? Say no. When you say try another way, it will allow you to send the code to SMS. The victim gets that code. And if they type it in response to the first fake Google message, it's game over. The attacker uses that recovery code. You don't realize that your account is being reset. You type in that code and it's game over. And let me say, this can happen with any SMS. I could say, hey, there's a tornado in your area. Would you like to be enrolled in the National Weather System's tornado warning system? Yes or no? And then the victim will go, yes, I want to be warned about tornadoes. They're like, we're going to send you a code. What you don't realize is that code that's sent to you in another message, it has nothing to do with this fake national weather system. It's like your bank account password reset code, or it's somebody resetting one of your passwords somewhere, and then your bank or stock account or email or Gmail or Microsoft sending you this code. And literally, attackers can make up any fake message like, hey, there's been a water break in your area. Do not use the water, boil water till further notice. We apologize for the inconvenience. Do you wish to be enrolled for proactive status updates about this event? And you're like, yes, who wouldn't want to know about the water pipe being repaired? They send you they're like, okay, we're going to send you a code, and you just don't know that code has to do with your bank account, and it's game over. I've even seen websites where people went to websites and it's like, oh, to activate this website, you need to put in the code we send you, but they're not sending the code. It's your bank account sending your code, or Facebook or Google or Twitter. And then the attackers are stealing that code to take over your accounts. So again, the thing is, you can't trust anybody, on the web or SMS messages or even someone that calls you to be who they say they are, right? They can be just anybody. Now I'm going to kind of keep on going. They could call you and do the same thing. They could send you SMS messages and PayPal and Instagram to do the same thing. You cannot trust anybody that sends you a message or calls you on the phone to actually be who they say they are. They can be anyone, right? And you're like, well, maybe I recognize their voice. Well, there's deep fakes for that as well these days. They can even social engineer tech support at the phone company. You had nothing to do with it. Like here's an example. And again, I don't have time, but there is this really cool hacking demo where a reporter wanted to see if a hacker could compromise his cell phone. And all he told the hacker was, he told the hacker his phone number and then what cell phone company he used. I think it was T-Mobile or Verizon Wireless or something, or AT&T. And that attacker downloaded 2 videos of crying babies to make it sound like there's babies crying. And then she called tech support of that guy, the reporter's phone company, and went, hey, I'm the wife of, Roger Grimes, and we're moving. And I was supposed to get the phone switched over, or plan for the phones to be switched over 2 weeks ago, but I got 2 babies that are sick and they're crying. Honey, I'm trying to do it. She acted like her husband was yelling at her. And she's like, I'm going to get it done, honey. I'm trying. What tech support person wouldn't want to help out a mother with 2 sick, crying babies in the middle of a move? And in that video, the tech support person not only gives her the password for the account and allows her to switch the account, but also allows her to buy another cell phone and charge it to his account. So it's a remarkable one. If you've never seen this video before, it's an amazing one to see how quickly. Another type of attack is any of the times you get these codes that are generated, they're called one-time passwords, or these 4 or 6-digit codes, and the numbers update every 30 seconds or every minute, and supposedly you only have that 30 seconds or a minute to use it. Well, a lot of them are based upon the current time, so they're known as time-based one-time passwords. So they update every 30 seconds, every minute, whatever, and it's based upon the time. Well, in order for that to work, the authentication system has to generate what's called a random seed, or a random seed value that it stores in a database. And if an attacker gets a hold of that database, if they get that seed value, they can use the seed value plus the algorithm that particular product uses, plus the current time, and be able to get the same code as you. And this has been able to do this for decades. Years ago, when I used to be a penetration tester, I used a product called Cain and Abel. You don't want to download that on the internet today. It's full of Trojans. But it used to be a really cool tool, free tool back in the 90s, where, like in this case, it would help generate RSA secure ID codes. So if you knew that somebody had an RSA secure ID, you first of all had to get a hold of that. You had to know the serial number that was usually printed on the back of the device, but the serial number and the seed, which they called the key, was stored in a database. And that database is either stored in this case, in RSA, or it's stored at the local client. And if an attacker gets it, you could then put the serial number and the key, the seed value, into Cain and Abel, and it would generate these codes. And you would know far ahead of time what the code was going to be, and then go use that code as if you were the user that was using the legitimate RSA secure ID token, and then log in as the victim. And this has happened in real life. Hasn't happened millions of times, but it does happen. The most famous example is when Chinese Advanced Persistent Threat broke into RSA, the company RSA, and RSA had everybody's seed values and serial numbers backed up on a server. The attackers found that server and then used it to generate any RSA secure ID codes they wanted to. And they eventually used it to break into Lockheed Martin and steal some secrets there. The Google Authenticator codes can be done the same way. Those codes are stored usually on a computer at the victim's network. If an attacker gets a hold of that code, they can generate these fake Google Authenticator codes. A lot of times too, when you do Google Authenticator, when you're setting it up, it sends you this QR code, and that QR code, really all that is a bunch of numbers or characters or symbols. But that code, that's your seed value. And if somebody finds that QR code, they can generate another unauthorized instance of Google Authenticator. It generates the same as your code did. A lot of people, they get the Google Authenticator code, they get it in an email, and sometimes they take a picture of it. So stored in their photo history. Sometimes they delete it, but it's in their email history and attackers find it there. And here's somebody complaining about exactly that. They had gotten this QR code for the Google Authenticator. They deleted it or saved it in an email. The attacker compromised the workstation, found that Google Authenticator QR code, generated another instance of Google Authenticator, and were able to take over that person's account and steal money off their Coinbase account. Google Authenticator, that QR code is an 80-bit secret key. The US government says that should be a minimum of 128-bit key for any time-based one-time password token. So what Google Authenticator uses is not really secure enough. But the worst part is that it never expires. So anytime any attacker finds one, they can use it to then generate the number. Of course, that's only true if somebody knows the Google Authenticator algorithm. Turns out that it is actually well known. It used to be an open source public algorithm. And there are many different software programs that allow you to generate Google Authenticator codes. One of them you can download now. It's a free program called Pharaoh. And all you have to know, again, is what the seed value is. And you put that in there and it will start to generate the numbers, based upon the current time. So anybody that finds this seed value, finds that QR code, you can convert the QR code into the information that it represents. And then you too can generate additional unauthorized instances of Google Authenticator. And again, sometimes you can actually force, most MFA options have reset options, or, you say, oh, I lost my password or I lost my MFA, and they'll ask you some questions and reset it. A lot of times they'll send the reset code to your email account. Well, that means, if I'm resetting your MFA using your email account, that means all I have to do is compromise your email account. Usually it's an alternate email account. And lots of phishers and spammers compromise people's email accounts. And then I can use that account to reset their bank password, their Gmail password, their Office 365 password, the Coinbase password, or whatever. And it goes to that recovery email address. And all you have to do is open up that email, click on a link, and you're in as the attacker. The worst ones are these password reset questions where they ask you questions like, what's your mother's favorite name? What's your favorite car? Or something like that. Most of that information can be looked up. It's not a secret, or it can be guessed at. Like if your favorite car, there's only like 100 different car models on the planet, and they don't change that much over time. And most people's favorite car is probably something like a Jaguar, a Lamborghini, a Porsche, or something, Corvette. It's probably not an AMC Pacer, right? So it probably wouldn't take me 10 guesses to figure out what your favorite car is, depending on what country I'm in. Matter of fact, Google did a white paper on this a bunch of years ago. And what they found out is that 20%, some recovery questions can be guessed on the first try 20% of the time. So 1/5 of the time, a hacker can just guess your question. 40% of the time, people are unable to successfully recall their own recovery answers. I think that means that if you forget your answer, maybe you should call a hacker because they have 50% chance of guessing it better than you. And then 16% of the answers can be found in a person's social media profile. And these attacks have been used in real world attacks to compromise people's accounts, like Sarah Palin, who ran for vice president along with John McCain against Obama and Biden. Some Democratic representative's kid used the internet, Google, to search on the answers. So he was trying to reset Sarah Palin's Yahoo email account. And they asked him 3 questions. And one was, like, where did you meet your husband? And it was in high school. He knew that story. The other was, what's your favorite sport? And she had played basketball, so he guessed at that. And then the other one was like, what's your zip code? And it turns out there was only 2 zip codes in Wasilla, Alaska. And he guessed on the first try, took over his account. Unfortunate for him, he then posted that in what he thought was a private chat called 4chan or 8chan, and he got arrested and put in jail over it. But anyways, what's the solution to these? Don't put in the real answers. When they ask you what's your mother's maiden name, Pizza 32, what's your favorite car, Pizza 71. You don't put in the real answers. This isn't Jeopardy, the game show. The only bad thing is that one, and you don't put in the real answers. That means you have to write down the question and the answers for every website that makes you do this. I do that, and I put it into my password manager. But you might want to put it in, a password protected document somewhere or something. But anyways, don't answer these questions with real answers. That's just asking for trouble. Biometrics, we know, can be stolen, right? Your fingerprints are not secrets or anything. Your retina scan, maybe it's not easy to get, but if I trick you or man in the middle, your eye scanner, I can connect, steal your retina. But let's say your fingerprints, your face are all over the world. And if I can steal them or get them, I can reuse them. And, how can anybody that steals your fingerprints, what are you going to do? Change fingerprints? Like back in June of 2015, everybody in America that had their fingerprints taken to get a U.S. government security clearance. I had gotten my U.S. government security clearance when I was working for Microsoft, and I was working at Customs Border Patrol back in probably the 2000s, early 2000s. My wife had her fingerprints taken when she was working at a shipyard when she was a teenager back in the 80s or 90s. But in any case, all 10 of our fingerprints, along with 5.6 million other people in the U.S., everybody that had applied for a U.S. government security clearance up until that time had that information stolen by another country. And, what do? Your fingerprints are out there. Anybody can have them. How can any system relying upon your fingerprint, really be sure to be your fingerprint? And it still happens today. Like here's an example breach back in 2019, where a very popular fingerprint and facial recognition vendor, they had an insecure database, and attackers, or actually researchers, found that anybody could access the website online and see anybody else's fingerprint or facial stuff and steal that information. When they reported that their website database was compromisable to BioStar never even responded to them for weeks. It took news media reporting on it for them to actually fix the problem. BioStar to fix the problem, but never even responded to the people that reported it, right? It's just, fingerprints get stolen. What do you do? Also, I've also seen that a lot of times when an MFA screen asks you for a code, like, put in the 4-digit code or 6-digit code, a lot of times they don't have account lockout enabled. Like if you put in your password wrong too many times, usually your system will lock you out, right? Say, oh, you can't try anymore. But for some reason, these MFA solutions frequently allow you to guess as many times as you like without locking them out, at least until it gets reported and the vendor fixes it. But here's an example, like that Instagram would allow you to guess up 250 times from any one IP address, and there was only 1,000 different codes that you could possibly have to put in. It was just a 4-digit code, so you only needed 1,000 guesses. Or maybe it was 3 digits, a 3-digit code. So you had 1,000 guesses for it. But, it turned out he only needed to use, only needed to rent on the cloud a couple of computers and have them very quickly guess 250 times a piece. And he was able to crack and bypass Instagram's initial 2FA option. And here's one where it happened on Slack. I love Slack, but here's, same thing where somebody could, repeat and put in and guess as many times they want without being locked out. And that's really, really common for these codes that the vendor forgets to put account lockout on them. It happened in cPanel 2FA. cPanel is a very popular web admin console. It could be bypassed in minutes via brute forcing. And here's another one, and another one, and another one. Here's one that would have bypassed the 7-digit code for a Microsoft MFA, right? It's it says there's rate limiting checks designed to prevent an attacker from repeatedly submitting all 10 million combinations of the codes, but he was able to crack the encryption function that cloaked that code and send multiple concurrent requests to crack it. So these sort of bugs, very, very popular. And let me say, if you put in MFA and bugs, you'll get thousands of options. MFA is nothing but software that's harder to patch. Every MFA solution has software with it. They all have bugs. And it really, even when they're reported, they're not oftentimes fixed for months. Like this one here, it was a bug that was reported on a particular, I think it was actually Uber in this case, But they're like, after ignoring for months, this client finally fixed this two-factor bypass bug after all, because initially they said, hey, it's not a bug, it's as designed, but it ended up being a bug. And let me say, every MFA solution can be hacked and bypassed. Every MFA solution has bugs in it, just like any software program, and they can be used and abused. The biggest bug I think I can remember was what was called the 2017 Rokup vulnerability. Back in 2017, most computers use this product from a particular company called Infineon. They either had software that generated encryption keys using Infineon software, or there were chips. You could literally have chips that had Infineon generated encryption keys. Microsoft laptops had what's called the TPM chip, the Trusted Platform Module chip on them. It used Infineon to generate secret keys. Most smart card manufacturers, the keys they generated were generated by this Infineon software or hardware on the chips. But somebody researching found out that for years, all of the keys made by Infineon could be easily guessed. Like, you're supposed to have public-private keys and nobody's able to guess the private one. Well, it turned out for years with Infineon, if you had the public key, you could quickly, within like 15 guesses, figure out what the private key was, which invalidated any solution. So it was all the Windows Enterprise laptops. It was most smart cards that had been generated for years, Apple laptops, TPM chips. I mean, it was really YubiKeys and everything. Tens to hundreds of millions of devices were impacted because of a software bug. And the sad thing is, most people that I talked to that were using smart cards around that time, they've never heard of this bug. The only way to fix this bug was to get a new smart card at the time. But we knew at Microsoft for years there were hundreds of millions of devices that were impacted, and millions of them were being still available. You could reach them on the internet even years later, although today most of them have expired. Hopefully the private keys have expired. But just know also in biometrics, anybody can fake any biometric attribute. I've been on 20 projects where we were paid to fake biometric attributes, fingerprints, retina scans, a lot of face ones, handprint geometry. Ones I did were fingerprints and probably facial recognition. But in every case, we were able to fake the biometric system using some sort of picture or Play-Doh or something. Even my favorite one was a lot of these fingerprint scanners where you press and hold your finger to be scanned. We found out that you could actually cup air over the scanner, blow warm air a couple of times, and it would energize the fingerprint with moisture and then log me in as the last person that had clicked the login or that had logged into that biometric scanner. So all it took was hot air to do it. And no matter how good the vendors say that facial recognition works, it never works as well as they, say they are. Like this one vendor tested 110 smartphones and found the facial recognition could be bypassed on like 40% of them, somewhere around there. And let me say, it's just on the Huawei, BlackBerry, Asus, Lenovo, LG, Nokia, Samsung, and Sony phones and stuff. I mean, that they failed a basic photo test holding a photo up there. Sometimes they had to Photoshop blinking eyelids and animated GIFs and things like that. But there isn't a facial recognition scanner that can't be faked. Every time the vendor says it can't be faked, they're just lying. Even like I love Microsoft's Windows Hello, I love it. But I've heard of old people will tell me like my little kid walked by my laptop and it logged them in as me. Well, certainly a 50, 60-year-old man doesn't look like a 2 or 3-year-old kid, but the facial scanner thought it did. And that's sort of the problems, and so on and so on. I'm kind of running out of time here, but again, I encourage you to download my slides and read more about these attacks. But the key takeaways are just know that MFA is not unhackable. MFA does not prevent phishing or social engineering from being successful, so you still have to pay attention to what you're clicking on. MFA is good. Everybody should use it when and where they can, but just know it's not unhackable. It's not unbreakable. And so the big other takeaway is try to avoid any MFA solution that can be easily socially engineered or man in the middle around, like I showed you in that first Kevin Mitnick video and some of the other ones. sadly, 80–90% of MFA solutions can be easily socially engineered around. And if you can, try not to use those types if you have the option. Unfortunately, it is the vast majority of types out there. If it's phone based, if you're asked to type in a code or something, it can be socially engineered around. And so really you want to make sure, and by the way, the US government has said since 2017, don't use SMS or voice call based MFA. In 2021, if you look at the bottom of the screen there, they said don't use MFA that fails to resist phishing. They said that includes SMS, voice calls, any that supply one-time codes. That's the Microsoft MFA. That's Google Authenticator MFA. That's RSA Secure ID, or receive push notifications. The US government is now saying in presidential orders for over a year now, don't use those types of MFA. Unfortunately, that's probably describes 90% of MFA. And they even just released another memo in 2022 saying, if you're going to use MFA, it should be phishing resistant MFA. Remember, 80–90% of MFA is not phishing resistance. No matter what MFA solution that you have, educate everyone about how that solution works, its strengths and its weaknesses, how to use it, what it does and doesn't prevent, and let them know about the common types of attacks, like the common types of social engineering attacks, so that they can be aware of them and try not to become a victim. So education is the key to defeating MFA weaknesses. Educate people, let them know how to prevent the easy attacks. With that said, I know I ran really, really long, but hopefully I can take a question or two. If I don't get to your question today, email me at rogerg@knowbefore.com, and I'll be glad to respond to your question. Of course, you can follow me on LinkedIn and Twitter. I talk about MFA all the time there.
Okay. Yes. So, Roger, I have a question for you. But before asking that question, I would like to compliment that it was a very insightful and engrossing session.
Thank you.
So my question is that MFA solutions are not being widely adopted by small to mid-sized enterprises because they think that it is costly, complex, and time-consuming to manage. So I want to understand that, does company size really matter when you're preparing for MFA deployment?
I think every single company and organization and person should use multi-factor authentication. Multi-factor authentication reduces probably, this is not a hard-coded figure, somewhere between 20 to 40% of attacks, somewhere in there. Like the most popular attack in the world is social engineering that tries to get you to reveal your password. And if you're using MFA, that attack does not work. So try to use MFA, but I would encourage you, and every company should do MFA, try to use a form that is resistant to phishing. The whole reason you're moving from passwords to MFA is to try to prevent phishing. A lot of the MFA out there can still be phished around, so try to use one that isn't easily phishable. That would be my thing.